Hello, everybody. Good morning, good afternoon, good evening, wherever you are right now. Hope everybody's doing well. My name is Rafael Campana. I am the Director of Engineering in the Developer Tools team. I'm joined by some of my colleagues, Sebastian Domine, he's a Senior VP in our team as well. Holly Wilper, Engineering Manager in the Platforms team, and Jackson Marusars, who is the technical product manager in DevTools as well. Together, we'll be guiding you through the CWES 52036. What's in your CUDA toolbox, CUDA profiling, optimization, and debugging tools for the latest architectures. Connect with experts session. We're going to get started here with a quick introductory slide, and then we'll go straight into the Q&A session. So please start thinking about any questions that you may have or any comments that you have. We'll be able to address it in either the main room or some of the breakout rooms that we'll be covering in details here in a little bit. So quick introductory of what we do and what we've been doing. So we are the Developer Tools team. We have products going from IDE integrations all the way to profilers. And just starting from the left-hand top quadrant there, the debuggers, we have CUDA GDB, Inside Visual Studio Edition, which runs on Windows, and Inside Visual Studio Code Edition that runs on multiple platforms, targeting different OSs. On the profiler side, I'm going to the next quadrant on the right, we have Insight Systems, which is your system level profiler. We have Insight Compute, which goes down into the kernel level and gathering metrics from the kernel. CUPD, which is our CUDA profiling tools interfaces, and also in NVIDIA Tools Extension, or NVTX, which is a way to annotate your code. It will show up in the different tools to give you better insight into what's happening during the execution of your program. On the bottom left, we have the correctness checker, which is Compute Sanitizer. Compute Sanitizer has multiple tools underneath it, 4 of them to be specific, between memory checker, init checker, race checker, and race checker as well. And that obviously is a way to confirm that anything that is happening in the execution of your CUDA application is not writing or reading outside the boundaries, doesn't have any race warnings and anything like that. And then lastly, on the bottom right, we have the IDE integrations, which is integrations that we have into different IDEs. We have integration into Eclipse. We have Visual Studio, as I mentioned earlier, and also Visual Studio Code. As far as other sessions that we've had, just wanted to make you aware of other sessions. Most of the sessions have already happened. However, as you may be aware, these are all recorded. So it's great to go back, and it's great information for you to touch on anything that we might have missed or you forgot to check on. So all these sessions are available. We have from debugging, profiling, optimizations. We have hands-on labs, which are great to have hands-on experience with the tools if you haven't yet, or if you have any specifics that you want to try out. And then we have a couple of Connect with the Experts, being this one. You can also obviously download CUDA Toolkit, and any type of support is available through our forums. And we have a site that gives you a guidance as far as what tools you should use for what purpose. I will introduce you a couple more of my colleagues that are here helping me in this session. Daniel Horowitz, he's going to be in the breakout room for platforms and mainly for Insight Systems, and he's a director of engineering for that team. Magnus Strengert, he is the engineering manager for Insight Compute, and he'll be in the compute profiling breakout room. Steve Ulrich, he's an engineering manager for debuggers, and obviously he will be in the debuggers and ID integrations. And then Aurélien Chartier, he's the senior software engineer for Compute Sanitizer, and he will be in the Compute Sanitizer breakout room. So let me keep that up and let you know. So we will be going into breakout rooms now. You can join there to, again, discuss anything specific, any deep dive conversations. You can select the breakout room by joining the drop down. You will see it was a gray bar at the top, and then selecting the specific breakout room that you want. And the list is what I mentioned earlier, and it should be once you click there. Do note that breakout rooms will be joined by other attendees. So it's not just going to be you and NVIDIA folks. It may be you and NVIDIA folks and other attendees as well. Just making you aware. If you want to stay in this room, which we'll be having conversations and kind of general conversations about questions that come up in the Q&A session, and between Seb and my other colleagues, we'll be talking about some of those questions. So if you have any general interest, we'll be definitely discussing there. And any specific ones will maybe guide you to the breakout room. So yeah, so let's go and switch to that now. So Jackson, any questions so far that we should be covering?
Yeah, we do have questions coming in, so appreciate that from everyone. They can feel free to put them in the room chat, and we have people in the main room that can help, or for specifics, feel free to hop into the breakout rooms, as Rafi mentioned. So first question, and I think we do have Holly here. So regarding the multi-node analysis, I do see that Nsight has recipe-based analysis for metrics. Question one, what is the impact of running the Nsight profiler on production? And question two, how do I get these two enabled with cloud providers? Is it even possible with cloud providers locking down their environment?
So there's a couple of things that are in there for DGGM. I'm assuming you probably mean DCGM. So the impact of running the Nsight profiler on your code really depends on how many features you have turned on, and also how big your kernels are. So if you have a lot of very small CUDA kernels, it will frequently take longer than if you have more normal sized CUDA kernels. We strive whenever we add a new feature to not add anything into the tool that's automatically on that has more than 5% overhead. For the second question, there are some features that you will have a hard time getting enough permissions to get in a cloud environment. For instance, if you want access to the CPU or GPU metrics on the actual hardware, you'll have to go through some particular steps and they'll have to be enabled. But what we do in those situations is we give you the data types that we can, and then we just cannot make available the rest of the data. So we try not to leave you with no data whatsoever.
Thanks, Holly. Another question, a little bit more of a high level one, and I guess worth laying out. So is it the same tools for embedded platforms like Jetson, or are these just for big CPUs, I guess, or big GPUs? And I toss that one to the room.
I assume it's not just Nsys, Jackson. It was overall.
Yeah, I think it's just the tools you talked about in the first slide.
Gotcha,
Maybe you could talk if some of them are different, I guess.
Yeah. So all of our tools are supported on across multiple devices, right? We're going from your desktop, right? Your workstation, let's say. We support, connecting to supercomputers, as well as embedded and drive platforms. So all of these ID integrations, debuggers, compute sanitizers, and providers are available in some way or form there as well.
All right, thanks, Rafi. This one may be applicable to more users. My application uses Python with libraries for the CUDA code. Do these tools help with that?
So yes, so the tools do support Python. I don't know, Holly, if you want to touch on NSYS, since it's quite used
Yes.
there.
So Insight Systems recently added statistical Python sampling. So basically, if you turn that feature on every X number of seconds, we'll collect a full backtrace of what's going on in deep into your Python code and make that available to you. Certainly, we work with Python codes, but we don't show as much of the information about individual levels in that code, other than the new feature. And we will be expanding that feature in the future to cover some other Python use cases and to merge those backtraces with the C++ backtraces we have available now.
Should we talk about debugging CUDA code within a Python application as well? This is supported in our debugger tools.
Yeah, so debuggers do support Python as well. So we have, as you may know, CUDA Python, and anything that triggers any type of CUDA kernel as well on the target side, on the GPU side, it will be able to support it just like any other debugger. We also support Fortran if you're interested in that too.
So we have a good question in the chat. Should we?
Oh, yeah, I
respond?
see it, Sebastian. Sorry, can you hear me?
Yeah, we can hear you.
Okay, sorry. I tried to toggle my camera and it turned off my microphone. So we'll table that. So follow-up question on the cloud environment. If I get a compute with NVIDIA GPU, will I be able to run Insight Systems without any specific permissions given by the cloud provider? It might be missing hardware counters.
In general, that's correct. There are some other features that will be turned on based on the paranoia level of the Linux you're running, for example. So those features might also not be entirely available, but your basic trace functionality should all be there, and some of your other functionality will be there as well. So you may be missing things like our operating system trace requires you to have paranoia level of 2 or lower, and the same for our CPU backtrace information. But you'll still get all of your trace information, all of your correlation data. And if you go to our documentation, you'll be able to find out specifically what things you need to turn on in that environment or ask for within that environment to get additional data.
Okay. The periodic sampling of the hardware PM though requires additional privileges.
Correct. Correct. The hardware counters, yes.
Here's a related one on Insight Systems. What is the recommended way to profile multiple nodes simultaneously with Insight Systems?
So what we recommend for that is actually running one instance of Insight Systems per node. So for instance, if you were using MPI to launch your jobs, you would do MPI run NSYS and then whatever the rest of the command was for what you were trying to analyze. This will generate you one report file per node, but with the new multi-node analysis that we've added with the most recent release that came out this Monday, you'll be able to take that data and analyze it all together as if it was one report and see statistical information and show some graphed information in Jupyter Notebooks inside of NSYS.
Thanks, Holly. And another question about tool support. Can I use these tools for OpenCL applications?
So no, the tools support CUDA right now. OpenCL, there's no plan to support OpenCL.
Thanks, Rafi. So we have one here about roofline. What does it mean if my kernel isn't near any of the roofs in the roofline chart? Rafi, I don't know if you want to take that or if you want.
Yeah, I mean, it means that you have room for optimizations. You can definitely, it's pointing out the fact that hardware can, you're leaving room for optimizations on the table, basically, so that the hardware can definitely is not being fully utilized. So in the roof line, there's some at the bottom. There's some guided point that will tell you what potentially you can change to make things potentially run faster, better occupancy. You know, all those metrics that we collect. But yeah, basically what it means is that your kernel is not as occupying or going as performant as it could go from a hardware perspective.
And here's one I see right in the chat. What is the best way to debug MPI plus CUDA code?
Well, hang on. I'd like to add
go
maybe
ahead,
one more
Sebastian.
statement to the work line. It's taking basically dimensions to the you know, it is basically isolating each dimension of what can be a peak performance, you know, individually, but it might be impossible to maximize basically all the roof lines that define performance. So sometimes you have to make trade-offs between what the roof line indicates you can reach versus other constraints of the performance, right? Registers, number of registers, shared memories. There are some trade-off, you know, sometimes that you have to trade. So it's an indicator, but it's not a mean that, you know, it's always possible to reach those peak performance, because there might be basically constraints that makes it not quite, you know, feasible. So it's a theoretical limit, right? Right, Rafi. I want to make sure that developers don't spend their time trying to optimize something that may not be possible, because when you combine, you know, those roof lines with a complete picture of the performance profile, sometimes you just can't get there, right? But it gives a good way to understand. Yeah.
Okay, and then I guess the question about debugging MPI plus CUDA. What's the best way to debug MPI plus CUDA code?
How to debug CUDA code. I assume this means being able to debug multiple ranks and be able to, like, basically asking for multi-node debugging, basically, right? Multi-process debugging. So our tools, and specifically CUDA GDB, which is where our Linux debugger is, supports a single process, and we enable third-party products, Alinea, you know, TotalView, ARM, to they have products that do support debugging of multi-ranks and multi-process, multi-node debuggers. So I would, in this situation, I would recommend using some of those products. However, you can visualize execution of such an application through specifically Insight systems to be able to see what's happening at a high level. But if you have debugger needs to be able to view variables or memory, then the recommended way is to use one of the third-party tools.
Thanks, Rafi. Here's another question we have. When should I be using NVTX? I don't know who wants to take that one.
Always.
Maybe a quick overview
That's
of what
the
that
short
is.
answer.
Yeah.
Yeah. Do you want me to take it?
Yeah, I
Sure.
think
Yeah, go
so.
ahead, Seb.
Just
All right.
Right.
Basically, NVTX is an API. It's a header file API that allows you to decorate your source code with, markers and ranges and nested ranges, where you can essentially decorate your application with semantics, colors or text or payloads to help basically recognize that certain phases of execution are happening during execution. And when you do that, that means that when you use any of our tools, being debuggers like Inside Compute for the API debugging part, or inside systems where you try to profile the system at the system level, or the holistic, system level of how the application is stressing the system and trying to correlate how the system responds to the process that is being profiled, to correlate, phases of execution of an algorithm to how the resources are being consumed. This is where NVTX come very handy, because you have a nice view on the timeline of those ranges of executions. And then you can map on that wall clock timeline, basically how the GPU is reacting, how the CPU is reacting, and what APIs are being called when those ranges are actually being executed. The other interest or the other advantage of NVTX is it's also used in a lot of our CUDA X libraries, and actually even SDKs coming from NVIDIA. That means that there's a comprehensive instrumentation of libraries like cuBLAS or TensorRT that already have NVTX instrumentation embedded within them, such that if you consume any of those SDKs or libraries in your code, and you happen to execute work through the use of those libraries, you will see basically in our tools through the NVTX instrumentation some context around what calls or what range of execution through those libraries ends up basically triggering work either on the CPU, on the GPU, and so forth. And so this is really, we cannot recommend enough to really use NVTX. It's very easy to use. There's zero overhead. It's when the tools are not attached or running, and basically it's minimal to no overhead at all. So it's really a great bang for buck for easy instrumentation, and really help provide necessary context to understand the profiling data around the application algorithms.
And the tools do, I think by default, have the option for tracing NVTX. But so as you run it through the tools, and you don't have NVTX enabled yourself, like Seb was saying, some of these libraries already use it, so you will see activities in NVTX row, or they may have their own row. So it will be already available. So you can see the benefit already from using those libraries. So we hope that you can use it as well.
Thanks. We've got one here. What's the difference between the GPU metrics collected by Nsight Systems and the ones collected by Nsight Compute?
So actually, some of them are is an overlap. Basically, Nsight Systems focuses on single pass, and what that means is that whenever the application executes, we're able to collect these metrics on a single execution. So there's some limitations to the hardware, where depending on the number and the type of metrics that you want to collect. In the case of Nsight Compute, we need to replay the kernel multiple times. So we will run it, like for example, the first time we will run, and we optimize so that the number of replays is as minimal as possible. But let's say you want to collect all the metrics in the world that we have available, then we run that kernel multiple times. In the first pass we run, we collect X number of metrics. The next one we collect the next one, and so on. Inside systems, due to the fact that we want to make it very as low overhead as possible, we make it so that we only collect those that are single pass. But there are some of those that you collect through Inside Systems that are available also on Inside Compute, so that you don't have to, for example, go like, I really want to see that metric that I saw on Inside Systems. You don't have to go back and forth between the two tools. Holly, I don't know if you had any extra detail you wanted to cover.
No, I think you covered it pretty well.
Okay, here's one for you, Holly. Can I directly access the profile data from an Insight Systems report?
So the Insight Systems reports are not designed to be directly accessed. However, we have export functionality that will give you all the information that's in there in several different formats. So you can get it in text, in CSV, in HDF, SQLite, Arrow. So you can get the information out in one of these formats and then process it afterwards. You can also take advantage of our expert systems statistics and our new multi-node recipe system to get data out of those reports as well.
All right, thanks.
Just a
Yeah,
quick update. I know that some of you were trying to be in the breakout room with Magnus, the Inside Compute profiler breakout room, and there was some audio issue. It is now open again. He's able to hear everybody, and his microphone is good. So if you were interested, you can jump over there as well, just so you know. Go ahead, Jack.
Yeah, thanks, Rafi. Here we've got one, just a toss out there. Are there any features added to the debugger or Insight Systems to help with debugging applications using portable acceleration in C++?
From the Insight Systems side, we don't have any functionality specifically for that, but there's no reason why it wouldn't behave like any other C++ profiling as far as our functionality is concerned. Rafi, can you address the debugger side? Or...
Yeah, I think it's a similar situation for the debugger. And to be honest, we haven't really looked into any details for that. But yeah, I don't see any reason that it wouldn't. Can we potentially look into giving you more insight into something? Sure, we could, but we haven't.
All right, thanks. This one, I guess, is for a couple any profiler. Do I have to modify or recompile my application to be able to use these tools?
For Insight Systems specifically, but I believe it's true for all of the profilers, you do not have to modify your application to run it. We don't require you to recompile with any specific options or make changes. You will get extra benefits if you add NVTX annotations to your code, as Sebastian mentioned earlier, and we'll be able to give you more information if we have debug information available. It'll help us do better symbol resolution and get back into the data. But as far as actually performing the analysis and generating data, no, we don't require you make any changes. You can run it on your production builds. It'll be fine.
Yeah, so that's the same situation for the other profilers, as Holly mentioned. On Insight Compute also, by enabling the -- line info, you can also get better correlation, or actually, sorry, I should take it back. You get correlation from your lowest level SAS, compiler generated code to your PTX, to your source level. That's the way that we can actually get information to map these. So you can see exactly, your CUDA C code was generating X number of instructions, and you can see details for those instructions. Also, on the debugger side, you do need to select the -G for generating debug information, and that can be for both the capital G and capital and lowercase g for the CPU, the host CPU debugging, and also for the GPU side.
Oh, thank you. We got one. Is there a static analyzer for CUDA code?
There's currently not a static analyzer code from NVIDIA. We obviously do dynamic through compute sanitizer, where you run the application and obviously you get the different reports from it. But doing static analysis is something that there are some products out there like VectorCast, and I think Coverity has some static analysis. But as of today, we do not.
Thanks. One about crashes. How do I handle GPU crashes from CUDA kernel bugs that lead to the GPU crashing?
Sorry, Jackson. Can you repeat the question?
Yeah. So how do I handle GPU crashes from CUDA kernel bugs, basically?
So let's first step back a little bit. You can enable crash dumps by default through an environment variable, so that whenever you have an application, a CUDA application that crashes, you get this what's called the crash dump file. You can also initiate the crash dump. So if you're in some loop and it's taking a little too long, you're able to tell the driver to go ahead and do generate a crash dump. After that, after having this file, this dump file, you can open it in the different debuggers. You can open it in CUDA GDB. You can inspect anything through CUDA GDB, as well as other debuggers like inside Visual Studio Edition, and you'll be able to see the state of where the crash happened, or where basically the snapshot that the crash dump was generated from. So you can see, if it has debug information, for example, you can see variables, you can see the memory state, you can select between threads and so on. But of course, it's going to be a little limited because you cannot do, single stepping from there. However, you see the state of where things crashed.
Thanks, Rafi. On a similar note to an earlier question, are the CUDA tools available on Jetson / do I need a host PC to develop on Jetson?
That's a very good question that I think comes up every year, Seb, if I'm not mistaken, right? So so with the latest versions of the tools, and I'll go through some of these, you don't need an actual a separate development box. So going through some of these, and I'll let Jackson also help me out here, but with Visual Studio Code Edition, inside Visual Studio Code Edition, you can run Visual Studio Code on the device, on the Jetson itself. And you can install the extension, the inside Visual Studio Code extension there. And at the end, it talks to CUDA GDB to do debugging. So you really don't need an x86 machine or a Mac for that matter to do any development. Second, going down the path here, profilers wise, also, I want to say it was spring of last year, we shipped Insight Compute and Insight Systems that also, the UI also runs on the target, on the Jetson itself. So you not only are able to run the CLI, the command line tools, which we've supported for a long time, but now you can run the GUI, the user interface from the Jetson itself. And then we have other tools that don't have a UI, for example, Compute Sanitizer. It's all command line based. You can still obviously use that on the device. Did I miss anything, Seb or Jackson?
No, I think you got it.
No, you got it, Rafi.
Yeah, we try and make sure all the platforms are supported. Another question.
I know that it was specific to L14 to to Jetson. But just one little comment is that for Drive, we do not support running the user interface on target for safety reasons, for memory constraint reasons, for several reasons. But yeah, I guess on the embedded on the embedded overall question.
Thanks for the clarification, Rafi. Yeah. Another question about cloud. Are there any issues developing CUDA in the cloud, specifically from a debugging perspective?
I don't see. I mean, I don't know why it would be any different. I mean, it depends on how you as a user end up using the tools. If you are SSHing into the system and doing everything there, or RDP, remote desktop into the system, there's no. I mean, it will feel and look the same as you were doing it locally. You can also do a remote session, meaning that you have the IDE, in this case Visual Studio Code Edition, and able to remote debug onto the cloud system. You can do that as well. Inside Systems and Inside Compute also support the remote scenario as well. So no, there's a lot of options that we provide. So I don't see any limitations to that. And I think Holly did comment on the fact that there are some limitations to maybe some CSPs, cloud service providers, that you may not be able to change, paranoia levels, and therefore your reports may not be as rich from Insight System. But I think other than that, I think you're okay to any cloud debugging.
That's all correct.
Thanks, Rafi. For an Insight Compute, is there a detailed description for all the Insight Compute metrics? I see the numbers, but I don't know what their meaning is.
Is there?
So we have the built-in knowledge base, right, Rafi? And we have the kernel profiling guide, which has kind of a lookup for each individual metric. And built into the GUI, there's a lot of information either in the hover text as well. But this is something we're constantly working on, right?
Yeah, correct. Yeah. So there's guidance there. And actually, you will see some new improvements coming up in the next couple of months that further push guidance as far as where you should spend your effort into what they mean and what you could potentially change and do. But yeah, those little sections that give you the information of if your bottleneck in any way or form is available in the report.
And I think we touched on this one earlier, but maybe worth reiterating. The question is, my Insight Compute source page only shows assembly. How do I get the CUDA C code showing up?
Okay. And I touched on that a little bit earlier, if I'm not mistaken. So you do need to compile your application with, and I might get this a little bit wrong, but just look for, I think it's -- line info. So if you compile with that, switch to MVCC, you will get the source correlation to source. There are times when, I'm not sure if this is the case for you, but there might be times when the compilation of the binaries have built into it like the path to where the sources are. So let's say for whatever reason the source has been moved, or you move your application somewhere else, your binary somewhere else, then it wouldn't be able to resolve that file. But you should see a pop-up at the top that says, hey, we know the association to this SAS is kernel.cu. Do you wanna look for it yourself? And you can click on that and you'll be able to resolve it yourself. But it should have been pretty obvious. So my guess is that in this situation, you just need to add the dash line info.
Thanks, Rafi. Do the tools support other parallel programming paradigms like OpenACC, or does it have to be directly CUDA code?
No. Oh, go ahead.
I was just going to say that specifically Insight System supports OpenACC. We support OpenMP. We try to support other APIs as it makes sense. OpenGL is another one we support.
Yeah, so the tools do support others, like Holly was saying, and even on other of the tools like Copy Sanitizer and Insight Compute, OpenGL interrupt, which is mainly basically having a CUDA or compute kernel and being able to do some calls into these other APIs like OpenGL and Vulkan and so on. It is supported as well, and this is part of the CUDA APIs. That is something that we support across the tools.
Right, and we support also optics in the CUDA tools. Right?
Correct, optics as well.
Yeah, thanks. What's the best way to determine if moving data on and off the GPU is having a performance impact? Would that be
Holly?
Holly, you want to?
I think it's Holly, right?
Some level.
Oh, did we lose your mic, Holly?
I can speak to it. But basically, within Insight System, there's a timeline and a trace of CUDA calls, as well as the collection of any memory transfers to and from the device, from the host device and device to host. So we can really observe a lot of memory copies that might be happening that could be superfluous, as well as PCIe transfers and the likes. So it's a good practice to start profiling with Insight Systems to get a bigger picture of what's going on in the system. Am I CPU bound, GPU bound, or is there any unexpected memory transfers that might be happening? It's also worth recognizing that some of those traces, especially as they relate to CUDA memory calls, fraying or copying, they do show potentially the backtrace into the driver, which may also indicate a stall or a semaphore waiting for some of those transfers to complete. And so you will be able to see easily that essentially the system is stalled waiting for a memory transfer to complete. And it's a good way to identify opportunities for improving those dependencies and stalls.
Yeah, thanks, Sebastian. Question here about debugging. Do I need to use GDB for my CPU code and CUDA GDB for my GPU code?
And the answer is no. CUDA GDB is fully integrated with both CPU and GPU debugging. So you use CUDA GDB, and it is a fully full-featured CPU and GPU debugger, and it's seamless between the two.
And the same is true for Visual Studio integration for Insight Visual Studio.
It's true for Visual Studio Code, and Insight Eclipse. For any of those, the CPU debug is included in the entire debug solution.
Okay, thanks. Does Insight Compute tell me what I should change in my kernel to make it run faster?
So I think we talked about this earlier. It does have some guided analysis, guided points at the bottom of each section, and the best way to do that is going from top to bottom. Each of those sections will tell you any information about if you're if you start off with being memory bound or compute bound, and it will tell you, okay, you should be looking at this section, or you should be looking at this area. And then you can go, from top to bottom, digging into potential performance changes that you can make to your code, and why we're pointing those out.
Thanks, Rafi. And I think we're having everyone move from the breakout rooms back into the main room. So I think we have a couple minutes if there's any last questions, or if it's time to wrap up. Appreciate everyone attending. I don't see any in the chat, but if anyone has anything, feel free to put it in there. Rafi, do you have any closing remarks or anything?
No, other than closing the whole thing, but as you pointed out, I think we have a couple more minutes, and I wanted to leave the time for anybody that had any questions that were in one break room that wanted to ask about others. Please go ahead and type it up in the next minute or so we can try to answer those before we end the session.
Do we have Daniel in the room?
I know it should have been back by now, I think.
Yeah.
So one question, Daniel, I think is related to Insight Systems. How do I profile my deep learning applications DNN layers?
Yeah. Okay, that's a little tricky, but if we're talking about PyTorch, there is a function on the autograd. So I think it's like pytorch.autograd.emit MVTX. Sorry, I don't have that exactly offhand, but I think if you search for it, you'll find something like that. And so if you write that in your Python script that you're running, so you would put like with that at the top before you go into your iterations for your, for your loops. And then when you profile, you want to turn on the MVTX trace and it will show up there. And then along with that, we have plenty, you'll see that on the timeline, and you'll also see, that'll be available for our statistics. And if you go to this talk, you can also apply multi-node data analysis on that as well to see how those individual layer names maybe behave across ranks.
Thanks, Daniel. Rafi, I think it's time to wrap up.
Yeah, it is. I wanna be sensitive to others going to other sessions. So hey, thank you again to my team. Thank you for helping out on this session, and thank you everybody for attending. And we hope that you enjoyed it, that you keep on using DevTools, and for those that have not tried it, please, the team here works hard to not only bring tools to new architectures and to the latest and greatest platforms, but also bring joy to developing on NVIDIA platforms. So please, we're open to feedback. We're always, just like an NVIDIA culture, we're always fast to change things and implement things as much as we can. So yeah, thank you for joining, and good questions, and I hope you liked joining us. If you need to attend other sessions, please, I have the slide here that has all the slides for all the sessions for developer tools, but the catalog of GTC is wide open for you to go and check other content out. So again, thank you very much. And to exit, the only thing you need to do is close the browser window. And yeah, thank you very much.